this. All right. We're figuring that out later while I'm not recording. Let's do one more example here that has a convolution integral. So let's see if we can solve one. Let's look at a problem out of the book. I want to do number 46 on page 290. We've got y prime plus 6y plus 9, integral from 0 to t, y of tau d tau equals 1, y of 0 equals 0. This is the convolution integral. Remember, for your convolution integral, just write this off to the side. If you have f of tau, g of t minus tau d tau, that you're trying to take the Laplace transform of, that's just the Laplace transform of the two functions multiplied together. In this case, I have a y of tau. My g of t minus tau would just be 1. So when we take the Laplace transform of that piece, we would just do the Laplace transform of y, which we've been representing as f of s, times the Laplace transform of 1, which would be 1 over s. So to that end, we would have s f of s minus f of 0 plus 6f of s plus 9 f of s times 1 over s equals 1 over s. Again, this piece is coming from the fact that we're doing the Laplace transform of y, which is here. Don't know what that is. That's our unknown. Times the Laplace transform of 1, because that's our rule for taking the Laplace transform of a convolution integral. F of 0 is 0, so that's going away. Oops. Sorry, I messed up. Oh, I didn't. Okay, we're good. We've got an f of s times an s plus a 6 plus a 9 over s. That has to equal 1 over s, and then divide. So we have 1 over s over s plus 6 plus 9 over s. We could simplify that. I could multiply top and bottom by s. That makes it a little bit easier to type in too. Just to clear the fractions, we would have 1 over s squared plus 6s plus 9. And actually, I'm going to go ahead and just write this as 1 over s plus 3 squared. You could just type, again, you could type this into GeoGebra. I just don't feel like flipping windows. And this worked out nicely to be able to do the inverse Laplace transform for. If this were just 1 over s squared, we would have a t. That would just be t, right? However, since it's a plus 3, oops, I don't want parentheses around that. It would just be a t, but since it's a plus 3 in there, I need to multiply that by that e to the negative 3t, because this is another one of our translation theorems. So this would give us what our answer is for this particular, what we refer to as an integro differential equation, because it involves both an integral and a derivative. Again, the big thing about this particular example was being able to do the Laplace transform of that convolution integral.